When interviewers evaluate junior data analysts, they don't usually start with advanced SQL. They start with simple questions, not because they are easy, but because they reveal how a candidate thinks with data. In this video, we'll walk through 10 SQL questions interviewers commonly use and explain what they are actually looking for. We'll work with two realistic tables: employee data, where we have employee details like role, department, and manager, and another table, employee activity, where we have daily employee activity. One important thing to remember throughout this video is one employee can appear multiple times. Most interview mistakes start when candidates forget that. Let's see our first question. Question number one. Find the first day each employee became active. This is usually where interviewers start. They want to see if you can identify the first occurrence of something. Before writing a query, let's see the table. From EMP activity 5. We have EMP ID, EMP name, employee activity, department, hours worked, tickets resolved, and status. Our question is, find the first day each employee became active. So using the activity date, we can find the solution. Let's write a query. Select EMP ID, EMP name, minimum activity date as first active date from EMP activity where status equal to active, group by EMP name and EMP ID. Each row now shows the first day an employee became active. This is very common pattern in interviews and real dashboards. Question number 2. Find active employees who never work more than 6 hours. So we'll use the same table here. We have same columns: employee ID, employee name, activity date, department, hours worked, tickets resolved, status. To solve this question, we use hours worked column. Let's write a query. Select EMP ID, EMP name from EMP activity. Date status equal to active, group by EMP ID and EMP name. EMP name having max hours work is equal to 6. Let's run the query to see the solution. These employees like David Anderson and Daniel White were active but never crossed 6 hours on any single day. This shows correct use of aggregation conditions. Question number 3. Find the employees who worked in more than one department. We use same table, and this time we use department column to find out the department. This question checks whether someone can detect changes over time. Let's say if I may work on HR department from my previous month or previous month, but maybe now I'm working on support department. So this checks someone can think like that. Select EMP ID, EMP name from EMP activity, group by, I can see EMP ID and name, EMP ID and name, having count, this strength, department greater than 1. So this query will give us a solution which employees worked on more than one department. Let's see. Here we have Aditya Sharma, Arav Patel, and John Miller has worked on more than one department. These employees like Aditya Sharma, John Miller appeared under multiple departments. This often matters in audits and reporting. Question number 4. Find the employees with no activity in the latest month. This question checks whether you can identify recent inactivity. Here we use activity date to solve this query. Let's write select EMP ID, EMP name from EMP activity group by the same EMP ID and name sign having max max activity date. Also select max activity date from EMP activity. Let's run and see the result. All these employees don't appear in the most recent data period. This is often used to detect attrition or data gaps. Very important question. Question number 5. Find the employees who worked every day in a month. This checks completeness of activity. Let's find the employee who worked every day in the month. Select EMP ID, EMP name, activity date from EMP activity. We have to extract month from this activity date. Date format, activity date, percentage y dash, percentage n as month. Count distinct activity date as EMP days. Group by EMP ID, EMP name, and month. This query will give us employee active days, like EMP days, the number of days that an employee worked in the particular month. Now let's find the active days in a month. Select this date format, month, and we also need total active days. This as total days, group by month. This query will give us a month level total days. So there are 4 months and the total days in each month. The question is employees who work every day in a month. To find the employees who worked in every day in a month, we have to join these two queries. So let's just put this into a subquery and call it as E join this below table and call it as M. Select start from and on E dot month equal to M dot month, where E dot EMP days equal to M dot total days. This employee arrow pattern worked every single day in that month. This question often separates comfortable SQL users from careful users. Question number 6. Employees whose tickets double month over month. Now the difficulty increases. This question checks month over month growth. Let's try to query. Select EMP ID, EMP name, date format, activity date, sum of tickets resolved as tickets lag, sum of tickets resolved over partition by EMP ID ordered by this month as previous tickets from EMP activity group by EMP ID group by EMP ID name and month. Let's see what this will give us. Now we have employee ID, employee name, month, tickets, and previous tickets. So let's find the whose tickets double month over month. Let's add a subquery here. Let's start from where tickets greater than or equal to previous month tickets into 2. Let's run the query. These employees like Daniel, White, David, and Anderson double their ticket count compared to the previous month. This checks whether you can compare periods safely. Question number 7. Employees performing above team average. To find the solution, we also need another table, which is employee data, where we have team details. Here we have employee ID, employee name, role, and is manager, department, and salary. This question checks relative performance within a team. Let's write a query. Consider this table as A, and now A.emp ID, A.emp name, D.manager name, comma, sum of A dot tickets resolved as EMP tickets, join EMP data as D, A on A.emp ID equal to D.emp ID. Group by EMP ID, EMP name, and manager. Let's run the query to see employee tickets and manager level. Now we have a manager level details like employee with his manager and their total tickets. Let's continue the query. Put this into a subquery. From manager name, average tickets, average employee tickets as ADG, average team tickets as T, group by manager name. Let's run and see the query. Now we have manager and average team tickets. The question is employees performing above team average. Now we have both team tickets and average team tickets. Our team tickets is this. We just copy it above. C join this C dot emp id, e dot emp name, e dot manager name, e dot emp tickets from Azam on e dot manager equal to dot manager name, where e dot emp tickets greater than m dot average team tickets. Let's run this whole query to see the result. All these employees like Arrow Patel, Neha Iyer, Brian Thompson, Ravi Kumar perform better than their team's average output. Question number 8. Managers who depend heavily on one employee or more. This question checks whether a candidate can identify risk caused by over dependence on a single employee. Let's write a query. We use both employee data table and employee activity. We have a manager name here, and using this manager name, let's find out who depend on heavily. Select same query, d dot manager name, comma a dot emp id, sum of tickets resolved as emp tickets from emp activity as a join emp data as b, on emp a dot emp id equal to d dot emp id, group by manager name, a dot emp id. Let's run and see the result. Now we have manager name, employee ID, and employee tickets. Let's write a subquery. Select manager name from the subquery as T. Group by manager name having max of EMP tickets greater than 0.3 into sum of EMP tickets. Now this query will give us a manager name who depends on more than 30% on his employee. This manager, Harish Malhotra, rely on a single employee for more than 30% of their team's tickets. This can indicate a risk if that employee becomes unavailable. Question number 9. Employees with more than 5 consecutive active days. This checks whether someone can detect tweaks. We use the same employee activity table. Let's write a query. Select EMP ID, EMP name, activity date, date underscore sub, activity date, interval, row number, over, partition by EMP ID, order by activity date. Day group from EMP activity where status equal to active. Let's run and see what it will give us. We have employee ID, employee name, activity, and group date. Let's put this into a subquery. Select EMP ID, EMP name from ST group by EMP ID, EMP name, group having count star greater than 5. These employees, Arav Patel, Emily Brown, were active for more than 5 days in a row. Question number 10. Longest gap between working days. We use again same employee activity table. This is the hardest date question. It checks gap detection between dates. Let's write CTE here with gaps as select EMP ID, EMP name, date difference, activity date, comma, flag, activity date over partition by EMP ID ordered by activity date as gap days from EMP activity. Now let's select EMP ID, EMP name, max gap day, max gap days as gap days from gap group by EMP ID, EMP name. Let's run and see the result. All employees shows the longest break each employee took between 2 working days. All these questions move from simple to real world time and pattern analysis. That's exactly how interview difficulty increases. They focus on correctness and clarity. If this video helped you think differently about analytics, you can like the video to help others find it. Thanks for watching, and I'll see you in the next video.